A bag of M&Ms has 3 red, 6 green, 2 blue, and 4 yellow M&Ms. Suppose that you randomly select 2 M&Ms from the bag, one at a time without replacing the first M&M. So we're going to let A equal to the event that the first is a red M&M, and B the event that the second is a green M&M. So we want to find the probability of A, that if you select only one M&M, that the first one is red. So we got to think about how many red M&Ms do we have, and divide that by the total number. So to get the total, we add 3 plus 6 plus 2 plus 4. That's a total of 15 M&Ms. We have 3 red M&Ms. And why are we picking red? Because event A is that the first M&M is red. So we think about how many red M&Ms do we have. That's 3 over a total of 15. Second one, probability of B given A. Now this one is without replacing the first. Okay, this is without replacement. B given A, it means that one red M&M has been chosen. So that means instead of 15, we only have 14 M&Ms. Now, if you have one M&M chosen that was red, how many green are left? There are 6 green left, so the probability is going to be 6 out of 14. Lastly, what is the probability of A and B? So we want to know the probability that the first one is red and the second one is green. So the first one is red. We have 3 red out of total of 15. Now, once the first red is gone, we only have 14 M&Ms that are left. Of the 14 left, 6 are green. So the probability of the second one being green is 6 out of 14, kind of like what we have in part B. So we have 3 out of 15 times 6 out of 14, and that gives you an answer of 18 out of 210. In this problem, we have a bag of red M&Ms, has 6 red, 3 green, 5 blue, and 2 yellow. Suppose you randomly select 2 M&Ms from the bag, one at a time. Now this time, it's with replacement, with replacing the first M&M. So for the second selection, because you replace the first M&M, we go back to the original conditions. Let A equal to the first M&M being yellow, and B is that the second M&M is blue. First, we want to find probability of A. So probability of A is that the M&M is yellow. So we take the number of yellow M&Ms, divide that by the total. So we have total of 6 plus 3 plus 5 plus 2, 16 M&Ms, and that'll be 2 out of 16. We have 2 yellows out of 16. B says, what is the probability of B given A? So given A, it means that the first M&M chosen was yellow. Okay, so if you chose a first M&M that's yellow, but we replaced it, that goes back to original conditions. So you choose an M&M, but you replace it. So we have 16 M&Ms. Of the 16, how many of them are blue? Because event B is that the second M&M is blue. That's 5 out of 16. And notice that because we replace the M&M, we have a total of 16. C says, what is the probability of A and B? So the first is yellow and the second is blue. So in the first case, we have 2 yellows out of 16. But that M&M gets replaced, so we still have 16 M&Ms, and of those 5 are blue. So we have 2 out of 16 times 5 out of 16. That's going to be 10 out of 256. In this example, we're given a table. We have manufacturer A, manufacturer B, and we have 3 types of hats. We got black, blue, and red. A, find the probability that the hat was red or was from manufacturer A. Now the word or is always going to trigger the addition principle, which is probability that it's red. The word or is plus probability that it was from manufacturer A minus the probability that it was red and from manufacturer A. So A plus B minus A and B. So how many are reds? We have a total of 41 red M&Ms out of 125. How many are from manufacturer A? So we have a total of 78 out of 125 from manufacturer A. And then we got to figure out how many are both. How many are red? So reds are going to be here and from manufacturer A. And that intersection happens right there. So those are 30 M&Ms, or sorry, 30 baseball hats that are both red and from manufacturer A. These 30, that's the intersection of manufacturer A and red. So we subtract 30 out of 125. If you add 41 and 78, subtract 30, that's going to be 89 out of 125. Part B says, Find the probability that if you select a hat, it's from manufacturer B and it's red. So once again, the word and, we're looking for the intersection. We're looking at how many hats are from manufacturer B and are red. The word and is intersection, and that's going to be these 11. Oh, I'm sorry, that was part C. So I'll go back to part B. So part C, that's going to be 11 out of 125 for manufacturer B and red. Now back to part B, how many of them are not red? So not red, it means I'm just going to cross out the reds. Red with a C, that means the complement of red. So how many are not red? So there's 45 that are black plus 39 that are blue for a total of 84 out of 125 that are not red. And then lastly, part D, it says manufacturer B or red. So once again, the word or triggers the addition formula, which is probability of A plus probability of B minus probability of A and B. So A is the event that it's manufacturer B. The word or is plus. This is the event that it's red minus A and B, so that they're from manufacturer B and red. So we have 47 total from manufacturer B plus 41 total that are red minus we got to subtract off the intersection of manufacturer B and red, which is 11 out of 125. So it's 47 plus 41 minus 11. That'll be 77 out of 125.